Hi, so with this session we will be learning how to complete the square. Now this is something when doing it at first is very tricky. So we'll be doing this step by step, and I'll be also covering a couple of things that you need to know or need to revise in order to do this properly. And it's important to understand why we are doing this. And the whole point of completing the square are these two main reasons. So if you want to write them down, it'll be useful because we'll be coming back to this when drawing parabolas. So the first step is the first reason why we complete the square is to factorize a quadratic trinomial where the factors are irrational numbers like surds. And of course, factorizing enables us to find any x-intercepts. So the first point will make more sense when we do an example. Now the second reason why we complete the square is because it shows by completing the square we can write the quadratic equation in turning point form. And the turning point form enables us to locate the turning point of a parabola. And this second step will make more sense when we actually start working with parabolas and drawing them. But just write these two down as your notes because it is important to understand why we complete the square. And the first point or the first reason will make sense after this session. Now just to use a visual example of what I just discussed with those two reasons why we complete the square. Parabola are like this. You can see there are important features, and two important features are the x-intercepts, and these are points that we have to find if the parabola has any x-intercepts. And now every parabola also has a turning point. Okay, that's always an important feature. So by completing the square, we can find any x-intercepts if there are any, because sometimes parabolas don't have any x-intercepts. For example, if I drew a parabola like this, you can clearly see there are no x-intercepts. But sometimes there are. And of course, to complete the square, we need to complete the square to find the turning point. And that is very important. And every parabola has a turning point, and that is a point that we must locate on our graph. So there are other ways to find x-intercepts, but you have to know how to complete the square to, of course, find this turning point. And this will all make more sense when we start drawing parabolas. Now, before we look at how to complete the square, there are two points that I want to revise, and that is one, factorizing. And factorizing something like this. And you notice that to factorize this, we've got a negative, a minus, a squared here, and it reminds us of a squared minus b squared. You can sort of see it appearing. The problem is this 11 isn't squared. And this is using the DOPS method because a squared minus b squared will equal, if you remember, a plus b and a minus b. That's the whole point of that's how we factorize. So first of all, we have to make sure what we are factorizing is in this form. Okay, everything has to be squared and there has to be a takeaway. And if there wasn't a takeaway, then we couldn't factorize this. So first, check, yes, there is a takeaway. Next, if we have a look at x minus 4, we can see that x minus 4, they're both being squared. So they're already being squared. Even though they're separated like by a takeaway in here, and they look like two different numbers, which they are, it's still, if we knew what x was, we will end up with one number anyway. So really x minus 4 is a number, we just don't know what x is. Now 11, we need to somehow square it. Now of course we can't just add a squared, and we know that in order to write a square, we first have to square root this, okay? And I'll put it in brackets and then square it. So now I have a squared minus b squared. So my a, you can show it like this. Your a is x minus 4 and your b is the square root of 11. And if it's more clearer to write it like this, a is equal to x minus 4 and b is equal to the square root of 11. So you can see it more clearly. And now all we have to do is put it in brackets, because a squared minus b squared is equal to a plus b and a minus b. And we've factorized it. So let's do that. So we have a is x minus 4, okay? And I'll change the color to emphasize we're adding the b now, plus, and what is b? b is the square root of 11, okay? And it's a surd, it's an irrational number, And in our next bracket, once again, we have x minus 4. And instead of plus, we have to take away b. Take away the square root of 11. And that's it. There is nothing else we can simplify in the brackets. We cannot add 4 plus the square root of 11. If we did add them, then we'd have an approximate answer because we'll have to round off our decimal. But we can stop there. And that's our answer in factorized form. So we'll see this again when completing the square. So it's important that you know how to factorize something like this. The next thing I want to look at is factorizing a trinomial, and this trinomial is, I guess, a special one, and you'll see why. Now, to factorize this, we can see that we don't have the coefficient of x is 1, so these ones are easy to factorize. We can get our brackets ready, okay? And of course, oh sorry, I forgot the x squared here. So we have x times x, which will give us that x squared. Sorry, I forgot to put this squared to begin with. Now, it's not all positive, so we can't just put plus and plus. So something times something to give us 16 that will add to negative 8. So we think of factors of 16. Well, I know that 1 times 16 gives me 16, 4 times 4 gives me 16, and we also have 2 times 8. Now, out of these factor pairs, which one is it possible to get to 8, whether we add or subtract? Can't be 1 and 16. Can't be 2 and 8, but I know that 4 and 4, if I add them, they can give me 8. So I'll be having 4 and 4 in here. Now I have to work out, am I going to have a negative in here or a positive? Now let's have a look. To get positive 16, they either have to be both positive or both negative. Now, if I had a positive here, then everything would be positive. But to get negative 8, I have to have minus 4 and minus 4, which will give me negative 8. So I put a minus and a minus. And once again, negative 4 times negative 4 will give us the positive 16, and minus 4 will give us a negative 8x. Now, because they are exactly the same, these are perfect squares. So we will write our final answer like this: x minus 4 squared. And that will be our final answer. So this trinomial was actually a perfect square. And we can actually see that before we even try to do this, because if we look at 8, half of 8 is 4, and if we square it, it gives us this 16. So we can see that it is going to give us a perfect square, because if we halve 8, which is 4, and square it, it gives us 16. So we'll be looking at this very soon when we complete the square. So now let's factorize this trinomial by completing the square. Now, you might be thinking, well, why can't we just factorize it quickly? Why can't we just do this? Get our brackets ready, like we normally do, and x times x is x squared. Over here, you notice there is no coefficient other than 1. Okay, that's important. To complete the square, you can't have a number here other than 1. Now, so x times x is x squared, easy. So now, something times something to give us 5 that can add to negative 8. So let's try and work out some factors of 5. Well, I know that 1 times 5 is 5, and that's it. So, is it possible for 1 and 5 to ever get to 8? Well, 1 plus 5 is 6, and 5 minus 1 is 4. There is no way we can get 8. So that means we cannot factorize this using integers, using numbers like, 1, 2, negative 4. It's impossible. There is no way we can do this. So we have to come up with another method to factorize this. And you can clearly see that we can't do it the normal way that we've known, because it's impossible. So to factorize this, we have to complete the square. Now to complete the square, we'll start with step 1. And step 1 is we have to halve the coefficient of x and square it. Or a shorter way of saying it is halve b and square it. And that's how I remember what to do. I just think to myself, halve b and square it. So let's make sense of step 1. So if you remember, the standard form of a trinomial is, we can say ax squared plus bx plus c, and b refers to the number in front of x, the coefficient of x. So for this trinomial, b is equal to negative 8. And the first step in completing the square is we have to halve b and then square it. So to halve b, or to halve any number, all you have to do is get the number, in this case it's -8, halve it, divide it by 2, and then we have to square this. And that's it. So to do this, well, first let's go, is it possible to go 8 divided by 2? Yes, -8 divided by 2 is -4. So that was pretty easy. It gave us a whole number. And we square this, and we always end up with a positive, because if you have a negative in here, we are going to be squaring it. And the square of -4 is positive 16. So we've got that 16, and we'll be using this in our next step. So just to recap, all we did was we got b, which was -8. We had to halve it, then square it, divide it if possible. In this case, 8 divided by 2 is just 4. Square the -4, and we got our 16. So with our first step, we've got step 1 here, we got our 16. Our second step is to add this to the expression. So add step 1 to the expression, which was 16, writing it after the x term. So there's our expression, the trinomial. So I'm going to add it to the equation, but after x. So our next step is, well, x squared is just x squared minus 8x, we write it again. Now here, this is where we have to add the 16, okay? Sorry, I just realized I wrote this equation wrong. We didn't have plus 16 in our question. We had 8x plus 5. I am sorry. So just change that. I accidentally wrote 16. So the 16, we add it after the x. And now the third step is to balance the equation by then subtracting what you added. So what that means is, can we just add 16 to this trinomial here? We can't just add 16, because if we just add 16, we've changed the whole expression. We've changed it completely. So to add 16, to balance it, we have to then subtract 16, okay? And now that plus 5 is on the end. So I've put in green what I've added. So just to recap, I accidentally wrote 16 to begin with, so it should have been plus 5. Now, we can see what we have done. Step 1, we had to halve b, halve the 8 and square it. We got our 16. Step 2 and 3 was to add the 16 after the 8x, and then of course subtract it to keep the expression balanced. And of course we have plus 5 in the end. So everything is still here, the x squared, the minus 8x, the plus 5. We have just added the 16 and then subtracted it. Now, step 4 tells us to factorize the first 3 terms, which gives you a perfect square. So now, to factorize the first 3 terms, we sort of have to group them. So let's group the first 3 terms, x squared minus 8x plus 16. Now this minus 16 and plus 5, they'll stick together, and we'll add those together in a minute. Now, to factorize this, remember we had the example before, which was the same thing here. It was a perfect square. So whenever you complete the square, when you group the 3 terms, the first 3 terms, which is the trinomial, you will always have a perfect square. Okay? And we put our x here. Now, to know if you're going to have a negative or a positive, check and see what you have here. Here we have a negative, so that would be a negative. If this was a positive, we'd put a plus here. And to know what number to put in here quickly, what was half of b? Half of b was 4, and therefore it will get our 4 in there. Now, if you factorize this the long way, like we did before, something times something to give you 16, that adds to -8, you can do it the long way. And don't forget, x minus 4 squared, it's saying x minus 4 times x minus 4. And that will give us x squared minus 8x plus 16. So I'm just trying to show you a shortcut to do this when completing the square, and that is, the shortcut is, all you have to do is put your brackets, put the square, put the x here. You know it's a negative if you have a negative in between the x squared and the 8x, and then put the number that was half of b, and the value that was half of b, half of 8 was the 4. And that's it. And then, now here, minus 16 plus 5, that is simply minus 11. All right? Now, at this stage here, we have this form here is called the turning point form. Okay? And this is extremely important because at this stage, I can see what the turning point will be for our parabola. And like I said, we'll learn how to use this later on in the unit. But for now, I want you to just have a look and see how this is in the turning point form. You notice how we have brackets here, and we've got x minus 4, and it's being squared. So turning point form has to have a square somewhere. And in this example, we've also got a minus 11 here. Okay, and this is in turning point form. So just keep that in mind. But now at this stage, we can actually keep going. So I've just added some extra steps. So we factorized the first 3 terms. So number 5, we did that. Simplify the last 2 numbers and identify the turning point form. I just added that in now. So just write that down. And remember, we have the turning point form here. And we added the minus 16 plus 5. That's what it means to add the last 2 numbers. And now we are going to do step 6, which is factorize, if possible, using DOPS, difference of perfect squares. Now, sometimes you stop here because it's impossible to factorize it. And that is, to know when it's impossible is when you see no negative here or anywhere else, and if this was and you see a plus. So if we had a plus here, okay, you cannot factorize this. And that's telling us our parabola will have no x-intercepts. It could be up here, it could be down there, and so we stop here. We cannot factorize this. So just keep that in mind. But with this example, we did have a takeaway, so we can factorize this because it's almost in the form of a squared minus b squared. And if you remember at the beginning of the session, we actually factorized this already. We have done this already. And we'll do it again just to make sure you got it the first time. And that is, well, to have it in the form of a squared, I'll just put it up here, a squared minus b squared. You should have this written down already. We need this 11 to be squared. So let's do this. Let's square root the 11 and then square it. Okay? And then this is going to be our a. The square root of 11 is going to be our b. All we're going to do now is put it in brackets and we are done. And we know that a squared minus b squared is saying a plus b bracket a minus b. So a is x minus 4 plus b, which is the square root of 11. And next, in these brackets, we have a again, a minus 4. This time, take away the square root of 11. And we are done. We have factorized it. So, by completing the square, we can see 2 things. Turning point form, and if it's possible from this point, we can then factorize it. And this, in factorized form, we can see the x-intercepts. Okay? So this whole process is quite hard the first time doing it. That's why you need to keep practicing, and practice makes perfect. And of course, to factorize a trinomial like this, where something times something to give you, in this case, 5 to add to b is impossible, you can see why it wasn't possible. Because in our final factorized answer, you notice we had the square root of 11. We had irrational numbers, surds. That's why we couldn't just do this the normal way. So let's do one more question for this session to practice how to complete the square. So remember, we'll follow these, write these main points down on how to complete the square, and eventually you won't even have to refer to this because it'll be embedded inside of you. So, first step is to halve b and square it. We know b refers to the coefficient of x, in this case, -2. So I'm going to halve -2, or halve 2, and then I am going to square it. And because I know that b was -2. Now, this is easy. 2 divided by 2 is going to give me -1 and squared. And of course, we end up with 1 squared is just 1, but 2 negatives makes a +1. Remember, this negative is inside the brackets, so it's also being squared. So we're saying 2 negatives, or negative times negative, and we're saying here 1 times 1, which is a +1. Okay, so now we have to, for our second step, we have to add this one to our trinomial. So we have to go plus 1, and of course, then balance it by subtracting 1. So let's just do that. Okay, so I have put in, when I halve b and squared it, I've got a positive 1. So now in my trinomial, in my expression, you can see I've got the x squared, the minus 2. Here I add the plus 1, then I have to minus the 1, and then I've got the minus 2 here. So in green, I have put in what the extra things. So now we have to now group the first 3 terms. So I'll change my color. Group x squared minus 2x plus 1. Okay, and minus 1 minus 2 I can just calculate. So I can do it now. Minus 1 minus 2 gives me minus 3. Okay, so we've combined those. But now we have to write this, we have to factorize this part here. The x squared minus 2x plus 1. And if you remember that shortcut, and that is the answer will be like this. Bracket, squared, you'll have an x. Now, it'll be either positive or negative depending on what we have here. And the first thing we see here is a negative, so we'll have a negative. And now, what goes here? It was half of b. And half of b was 1. And you can see, will this work? Because remember, we have 2 of these. We have x minus 1 times x minus 1. Let's quickly see if this works. Well, negative 1 times negative 1 is our positive 1. And minus 1 minus 1, when we sort of add them, we get negative 2. So perfect. We can see we have factorized it correctly, and using that shortcut method on how to factorize it. Now, I'll just write the negative 3 a bit closer so it looks like it's part of the equation. Now, what is this form here? Once we have grouped the first 3 terms and then factorized it, this is the turning point form, okay? And it's very important that you understand at this stage we have achieved something. We have located the turning point. And you probably can't see the turning point just yet, but you will soon. Now, we're going to continue with this and factorize using the DOPS method. Now, let's just do a check. Do we have a negative here? Yes, we can. So it is possible for us to factorize. But the problem is this 3 here is not a square. Because we need, remember, a squared minus b squared. So I'm going to square root the 3, and then I'm going to square it. And I like putting brackets to show that b is now the square root of 3. A is x minus 1. And let's put it in our brackets. A plus b in the first bracket. So x minus 1 plus the square root of 3. In our second bracket, a minus b. X minus 1 minus the square root of 3. And we are done. We have factorized it. And this will later on show us the x-intercepts. So just keep practicing, and I'll put more questions on later on. Thank you.